A proton is not like a living thing. It does not age. It does not degrade. A proton formed in the first seconds after the Big Bang is, as far as we can tell, identical to a proton formed yesterday. It does not carry the marks of its history. It simply continues to exist, unchanged. Every atom of hydrogen, every nucleus of carbon and oxygen and iron, every atom in your body and in the earth, and in every star visible from this planet, all of it held together by protons that have shown no sign of ever going anywhere. In all of recorded science, across all the matter we have ever examined, not one proton has ever been caught in the act of ceasing to exist. But there is a class of physics theories called grand unified theories, which predict that protons are not actually stable. These theories attempt to unify the three fundamental forces of particle physics into a single underlying framework. In doing so, they introduce rare processes that would allow quarks, the particles that make up protons, to transform into other particle types. If quarks can do this, even extraordinarily rarely, then protons can decay, not because of collision or radiation or external force, spontaneously from within, without any cause arriving from outside. The predicted decay timescale is so vast that the number itself requires context to understand. Current theoretical estimates place the proton half-life at around 10 to the 34th power years. Written out, that is a 1 followed by 34 zeros. The current age of the universe is approximately 14 billion years, a number with 10 digits. The proton's predicted lifetime makes the age of the universe appear to be essentially zero by comparison. If proton decay occurs, the long-term fate of matter follows from it. Normal stars exhaust their fuel and die within millions to billions of years. The stellar remnants, white dwarfs, neutron stars, persist far longer, but they are still made of protons. Over timescales approaching proton decay rates, even these remnants would gradually dissolve. Atom by atom, the structure of matter would come apart. Planets would evaporate. Solid objects would liquefy and then disperse into particles that build nothing. On timescales beyond even this, the decay products themselves would fade. The universe would be left with no atoms, no molecules, no solid matter, no structure of any recognizable kind. Only diffuse radiation and lightweight particles drifting apart forever, with no capacity to form anything that could be called a thing. A detector called Super-Kamiokande, buried deep underground in Japan and filled with 50,000 tons of ultra-pure water, was built specifically to catch protons in the act of decaying. Its sensors watch continuously for the faint signal of a proton transforming into lighter particles. It had been running for decades. It has never observed a single proton decay. This non-detection rules out the simplest grand unified theory models and pushes the proton half-life, if finite, beyond what current instruments can reach. But it does not rule out decay. No experiment has confirmed proton decay. No experiment has confirmed protons are permanent. They have simply continued to exist, as they have for the entire history of the observable universe, with no detected sign of ending.